Welcome back. In the last session, we have constructed the input and output data as X train and Y train. Now we are coming to the most interesting topic, which is designing of the LSTM network. But first of all, we need to import some required packages. So what we are importing here? We importing here dense class. We importing here input layer, LSTM layer, and we importing here the model class. I also have here import h5py of h5py package because I used it to store the trained LSTM model. So let's start. The first class which we have here is the input layer. We are using here functional API of Keras. There are two flavors of how we can design the neuronal networks with Keras. One is sequential API. This is the most known actually. And another one is the functional API, which is much more flexible. So I have decided to start to learn immediately with functional API, because later on you will see that you can do much easier, more complicated things with functional API. So first layer is the input layer. As always, every neuronal network needs an input. It takes a shape, it takes the argument batch shape. This is a three-dimensional array, so it consists of batch size, which we have defined as 64. It has time steps, which are 10, and it has number of parameters. So we are dealing with only with crude oil prices, and this is only one dimension which we have. So we are predicting the crude oil price. Crude oil price one is one dimension. So we have here only one. So suppose we would predict crude oil price for Europe, crude oil price for US at the same time steps. So we would have here two parameters, but we have only one. And the output of this class we are storing in the inputs one parameter. Secondly, we are defining the LSTM layer. This LSTM layer takes as arguments several parameters. So actually, if you look at Keras documentation, you will see that it has a lot of parameters, but we are dealing only with the most important ones. And here the first one is the number of LSTM nodes. So if I have here only one node, we can say that the whole layer, we can see the whole layer is a one node, is a one memory cell. This is what I have spoken about in the previous session. I said that LSTM layer is roughly equal to one node to one LSTM cell. This is really very roughly. And I have said it not to confuse you with too much information at that point of time. But now we know LSTM layer can take much more nodes. You can say also neurons. So here I have decided to use 10 nodes in the both layers. So we say 10 nodes, then we say stateful true. So we have decided that our LSTM network will be stateful. Therefore, we are setting it true. So second one is return sequences. It's a separate point, and we are setting here return sequence true. That means that it will return the whole sequence, the whole output sequence for every time step. So we have here 10 time steps. It will return a sequence of 10 outputs. And this one, the output of this layer will be the input of the next layer, which is actually this is a architecture of stacked LSTM layers. And you see that the output of this LSTM layer is stored here, LSTM1 Maya, and it goes as input into the next layer, LSTM1 Maya here. And if you look carefully on the whole structure, you see that the input layer is stored here in this variable, inputs 1 Maya. And this input goes, this output of this layer goes as input into the next layer here. So then we have output of the LSTM layer, which is stored here, LSTM1 Maya, and it goes as input into the next layer, into the next LSTM layer. The output of this layer is LSTM2 Maya. So now we have the structure, and now we need a dense layer. Dense actually is a fully connected layer, as you know from another neuronal networks, which are actually consisting only from such layers like multi-layer perceptron. This is a typical picture of neuronal network. They consisting of dense layers, and we need this layer to output our data. So it takes one argument, which is units. Units is again 1. This is the same as 1 here. This is only one dimension. We're dealing only with one thing which we are going to predict, which is the crude oil price. 1 unit. And this class takes as input LSTM2 Maya from here, and we have the output. So now we are defining the model. The model class takes 2 arguments, the inputs, which is the input layer, and the outputs, which is the output layer. This is the output 1 Maya. And this is already our regressor. So if we define the model, we have our regressor, we have our model. In the last step, we have to compile this model. So meaning that the whole thing, the whole structure will be built up and connected. So if we call this compile method, everything what we described here is going to be designed and connected. So we use this optimizer in the compile method. We are using optimizer, which is Adam, and we use loss function, which is mean absolute error. In the next sessions, we are going to see that we can use also another function, another loss function, which is called MSE, mean squared error, and we are going to compare which loss function performs better, mean absolute error or mean squared error, and what are the differences. So now we can execute this, and we see this is our LSTM layer. It has input layer, it has 2 LSTMs layer, and it has dense layer. In the next session, we are going to dive deeper into the structure, and we are going to look onto anatomy of the LSTM layer, and Until the next time, stay tuned, enjoy, bye.